Okay, so welcome to the second walkthrough of the second exercise, and I started describing a bit. Okay, let me flash here. Here I wanted to explore, I wanted basically to create something with a lot of nested functions so that debugging might be a bit more difficult. And I found this script online, only the model part. This is an SIR model. It's sorry. So this is an SIR model. It's the most basic toy model in epidemiology. Tries to define a bit how an infection progresses through population. I'm sure after the last years you know about it. The cool thing is that it uses a numerical solver. This Dissolve package is quite amazing. It can, in this bit of code, I write down an ODE system, ordinary differential equation system. And this makes, at least when you work with compartmental models like this, makes writing it very, very simple. You don't have to solve the equations, which I wouldn't even be able to mostly. I have a numerical solver doing the work for me. And it can be, it's very flexible technique. It's quite nice to have it as in the toolbox. You define your system, and then here I'm calling the ODE solver with the needed parameters. I need to initialize the states of the boxes, the compartments. There are 3, so I will need a vector of 3. I need the time steps, times in this case, and I need a vector with the parameters. In this case, there are 2, gamma and beta. You can check the model online. Then I want to create a matrix. The idea is that I want to explore the model space. This model space is simple enough because it's only 2 by 2. Not 2 by 2, it's only 2 variables. So it's a bivariate model space. You can imagine it. You see, you can plot it. When it gets a bit more complicated, like 3, 4, 5, 6 dimensions, of course, it becomes quite complex or impossible to visualize it. This function creates a matrix of the length is n. So you need as many parameter combinations as possible. And the other dimension is 2, in this case because of 2 parameter beta and gamma. We can test it. Let's see, let's set n equal to 10, just a small test. Parameter matrix, yes, empty, give some names, beta and gamma. Okay, then here there is already a problem. What is the problem? I should create a vector of 10. 1, 2, 3. Can count length. Very, very lazy. Yes, should be 10. Why? What is the problem here? Haha. Yeah. Yes. Wrong dimension. Here we already spotted one error. This should be. Aha. Yes. I forgot to mention. I forgot which errors did I put here. I have another screen here where I can read the solution eventually, so that you don't have to spend too much time on this. But I will try not to, going with you through the process. Now this should be, you saw it was this is a vector of 10. It should be on the other dimension, should be a column. I think it should run now. Yes, it runs. And yes, okay, this bit works. We already solved one error. Let's try to load this one. Many errors. Let's see. Perms matrix. I want again. I usually try to run to debug manually by trying to go inside. Here, RStudio is already telling me something interesting, but I want to go systematically and see what happens. So I try to create one parameter matrix. I didn't load it. Okay, now load the function. Let's create params matrix. Okay, so I have one to start with. And now I go inside here and test a bit. Okay, here I want to know how big was the parameter matrix, the n, so that I don't have to specify it in the function. 50, it was 50 here. Initialization, I always give the same, in theory you could study also what happens with different initialization values, but I made it simple. Here I give the initialization of the pools inside the function. Create times, this works. Maxinf, okay, I create a matrix of the max infected values for each value of beta and for each value of gamma. So this is a 50 by 50 now matrix. And this is the nested loop that I use sometimes even for 3 or 4 dimensions. This is only 2 dimensions. It's probably possible to follow. For each j, let's say j is the column and I is the rows. Let's say j takes the first column, then for each column you run it for i's, each one of these rows. This has an error. Let's go inside. So I set j equal to 1. Start from the first point. And then I can also check where did it stop. Didn't even run the second loop. Let me see. Testing j equal to 1, and then it blocks here because this is not even I. Doesn't run the loop. Let's say I equal to 1. This doesn't run. Gamma, there is one. This is too much. Yes, I think it was that one. The function search, so let's see. Now I think the function is loaded. Okay, I think that was definitely an error. There was just one parenthesis more. I could have just trusted RStudio. I don't trust RStudio in general. This doesn't run because I didn't load all the function. Here solved the model. Let's run the ODE. What happened here? This will give exactly the same error. Yes. So we know that the error happens here. Now j equal to 1, I equal to 1. I don't want to mess up. I want to be sure that I'm on the first step of this. It's here. Init makes sense. Times invalid argument to unary operator. I think it's here, so it's probably something in the search function. Can do this. I put in the memory the input for the search function, then I go running it. Same stuff. The solve is already loaded, probably loading it out. Init. Times to work. Init should be. So it takes input of function of time, and this is time. State, any state. It's y. Probably this one. The state. No, not the y. Yes, sorry, I wanted to because it's the basic. I pause and now I check a bit what was the problem. I don't want you to wait too. Okay, I found the error, and it was indeed not easy, this one. The problem was that it's inside here, and it's a bit difficult because the error message didn't help so much. This function loads pretty easily, loads well. It seems that there is no problem here, but then when you check parms, it's this. The problem is that this should be a numerical value. This is not a numerical value. Structure parms, parms. This is you see it's a numerical value plus a character named numerical. It's because I'm using this list. It should be either. I think this would also work without the name. It's probably not the most elegant. Let's see if it runs. It runs. So now it will take some time. This was one, but the solution that I found I think that is much better actually. Just it shouldn't be this parms list. Parms vector should be just a simple vector. Loading. And now let's wait for it to run. I'm sorry, but you will have to wait together with me. A bit of caffeine while I wait. Okay, it's already now. I don't need it. Last but not least, and I hope I didn't have anything else. Create a figure on the surface, plotting it. Yes, it's pretty decent. This is the surface, the parameter space of that model. Okay, to do it nicely, Z, X, and Y should get axis name. Anyway, you can check here. X parameter matrix 1. What was it? Parametrix 1, I think was beta, probably beta. Okay, so X, Y, X is beta. So what the variation of beta and the variation of gamma, what happens to the maximum people infected. And the surface is not extremely complex. It doesn't have many weird peaks or bumps because the model it's pretty simple. But still, it's not just a straight line. It's there are some trade-off between these parameters. To think about what it means, it's outside the scope of this this walkthrough. The last error, I have to say, it was pretty sneaky. I might have taken me like half an hour to find it, and I would have needed to check the manual if I didn't have the solution. I do hope that you didn't get too frustrated. A bit frustrated. It's physiologic. It's part of the exercise, but I hope it wasn't too hard. Well, I hope you won't hate me too much, and see you soon at the workshop.